Hello, YouTubers. Thanks for coming, Year 11s. So my Year 11s are currently in the room with me. They're all going to say hello. Say hello, everybody. What's up? Okay, so today we're going to have a look at doing an exam review for June 2017, paper 2 for the edexcel GCSE. This is the non-regional paper. So now my Year 11s have already started work on it, so they're going to be doing this, and I'm just going to they're going to try and stay ahead of me, and they can then mark depending on look and compared to what answers I'm giving. So, okay, I'm going to share my screen. Let's go share screen. There we go. I've popped out the chat. I'm also going to get rid of my face since I haven't got my clip cam. There we go. Share screen. I'll now get rid of that. And I should have my little chat popped out. I don't think my 11s, since they're in the room, I don't think they're going to be contributing on the chat today. So it's going to be a lonely lesson. Okay, right. So you guys, Mita, hi Mita, and Laura's in as well. Isn't that fab? Right. Okay, so I'm just gonna hide that little tab and I'll crack on. Okay, so question number 1, first question, really lovely question, just elements, compounds, mixtures. And of course, the question here is asking, so I need a calculator. I'm gonna ask one of my lovely Year 11s. Has anyone got a calculator, a calculator to borrow? So this question doesn't actually require a calculator. They're asking us how many different elements are shown in the formula. So the key thing here is that I have sodium, thank you so much, I have sodium, I have sulfur, I have oxygen, and I have hydrogen. So there are 4 elements in this. Other versions of this question, this here is a hydrated salt. And it's very common for them to ask all different questions similar to this one. So they'll often add, how many oxygens are in it? Yeah, in which case you'd have to go 4 oxygens there plus the 10 oxygens there, so 14. They might ask you the total number of atoms. That's another very common one. So there would be 2 sodiums, 1 sulfur, 4 oxygen, 20 hydrogens, and then 10 oxygens, and then you have to sum it all up. So lots of different versions of the question, and what they're doing is they're analyzing your understanding of formulae. That's all they're doing. Okay, so question number 2. Question number 2, balance the equation. So 1 sodium, 2 sodiums. Let's do that. Right, remember, right, the sulfate ion hasn't changed, so I'm going to treat that as a single entity. So I'm not going to count the oxygens including that. So 1 sulfate, 1 sulfate, that works. So 2 oxygen, 1 oxygen. Right, now I think it's going to be balanced. 2 sodiums, 2 sodiums, 2 oxygens, 2 oxygens. 4 hydrogens, 2 there and 2 here, so 4 there. That makes sense. So there you go, my equation is done. Yeah, next. Sodium hydroxide is manufactured in the electrolysis of brine in a diaphragm cell. Don't worry about the diaphragm cell. Yeah, you just need to know that this is the electrolysis. Sulfuric acid is manufactured in the contact process. Statements, 2 processes, tick the boxes that show correct statements. Brine is a solution. Brine is a solution in sodium chloride water. Yes, it is. A temperature used in the contact process is greater than 1,000. No. An equation for the contact process? Nope, doesn't balance. Not enough oxygens in the sulfate, so that's not right either. The reaction in the diaphragm cell are displacements. No, they're not. They're redox. The catalyst used in contact process is V2O5. That is correct. Unfortunately, guys, that there is what's called industrial chemistry. Industrial chemistry. I have done a YouTube video on this. See YouTube vid. I have done a video on industrial chemistry, and that there is where it comes under. Unfortunately, it's all knowledge based as well. That is all heavy knowledge. Next, notice though, it's only 2 marks. Yeah, 5 ticks for only 2 marks. It's not as bad as you think based on the score. Okay, how many periods? So the first thing is periods and groups. So a period is across the group, of course, is a column. So periods, 1, 2, 3 of them. Groups, 1, 2, 3, 4, 5, 6, 7, 8. So three periods, 8 groups. We're done. Next, how many elements are shown in the diagram on noble? 2 nobles, helium and argon. 2 nobles. What is the formula for magnesium fluoride? So Mg is 2+, comes from the periodic table. It's in group 2, +1, +2, +3, nothing, -3, -2, -1, nothing. So magnesium is +2, fluoride is -1. Cross and down, they're testing your ability to build formulae. So MgF2, nice and easy. Next. Calculate the relative atomic mass of a sample of silicon. Give your answer to 1 decimal place. 28 multiplied by 92.2. Add that to 29 multiplied by 4.7. Add that to 30 multiplied by 3.1. All divided by 100, the total of the percentages. I'm going to be really close to 28. I know that because there's more 28 than anything else. So if I get a number that's miles away from 28, I'm probably wrong. 28 multiplied by 92.2 equals, plus brackets, 29 multiplied by 4.7, close brackets, plus brackets, 30 multiplied by 3.1, all divided by 100. And I get an answer of 28.11, but it says to 1 decimal place, 28.1. I'm done. Next, dot and cross diagrams from bonding. Nice and easy. So just draw circles around the atoms. Make sure they overlap, because this is covalent. Covalent overlaps. Ionic, square brackets for ionic, no overlap with charges. Yeah, this is covalent because they're all non-metals. Right, in the gap, 1 set of dot and crosses in each one, and then make fluorine add up to 8. Everybody must add up to 8 except hydrogen. There's no hydrogen here, so we've got to add circles until they all add up to 8. Nice and easy. Low boiling point, WIMPs between the molecules. Next. Straight into it. The table shows the boiling points of some compounds with silicon. SiF4 have simple molecular structures, SiO2 is giant. Explain why the boiling point of SiCl4 is greater than SiF4. Right, so SiCl4 and SiF4 are simple covalent. What that means is that these molecules are going to have WIMPs between them. We understand that. They're going to have, this is here is a weak intermolecular force. You can't call it a WIMP in your exam. You have to translate that entirely out, guys. Do you all, Sophie, do you always treat ions as single entities when balancing? That's a really good question, Sophia. I'm sorry that it's taken me so long to answer it. So in terms of the complex ions, yes, the complex ions, if they haven't changed, you don't worry about breaking them up. Just keep them as a singular unit. And these happen a lot at GCSE. Another example is something like calcium plus nitric acid. What we realize is we're going to form calcium nitrate and hydrogen. Well, what you realize is this is the nitrate ion, yeah, and there's the nitrate ion. It hasn't changed, but there is 2 of them, so I need to balance for it. But I just treat that as a single entity. I hope that helps. It's a good question. Going back to the paper. So we're now talking and comparing WIMPs. Now, you learn, this actually comes from oils, because what you learn about WIMPs, and this is the nota bene, WIMPs, bigger molecules, stronger WIMPs. Please underline the as well. You can't say strong WIMPs, that's not allowed. Stronger WIMPs, yes. So what you have to do is you have to work out between these two, since they're both WIMPs. Yeah, we need to work out who's bigger, and you get that from the MR. So in this case, the silicon tetrachloride is going to be, silicon is 28 plus 35.5 times 4. That weighs 170. Silicon tetrachloride is 28 plus 19 times 4. That one's 104. Right. So the silicon tetrachloride, SiCl4, is a larger molecule. Larger molecule, MR 170 compared to 104 CIF4. So SiCl4 has stronger weak intermolecular forces. And I'd write that down in my exam properly. Yeah, so SiCl4 has stronger weak intermolecular forces. So higher melting point. So higher boiling point, since they asked it in the question. Let's do a bit of questioning to my Year 11s. Year 11s, I've just finished the comparison of size. Put your hand up if you got that question right for me, please. That is, can I just point out that there, in terms of paper 2 levels, that there is the very first level 8-9 on that paper. That will have a less than a 20% correct output. This is question, yeah, this is question number, well, I have to go all the way back. Question number 2F, part, it says, explain why the boiling point is greater. And they say, bigger molecules give the MR stronger WIMPs. Yeah. What are a Faraday? A Faraday is the, 1 Faraday is 1 mole of electrons. You no longer do electrolysis calculations. They got removed when it changed over 1 year ago. So the great thing is you do not have to do any calculations. In the old days, you'd have to use Q equals I times T, current times time, to work out the charge. Then you'd multiply the charge by the Faraday constant of 96,500 to get the number of charge divided by, I can't yet. Anyway, it spits out the moles of electrons. Nope, it's all gone, been deleted, you just skip it. Explain why the boiling point of Si is much greater than the boiling point of, okay, so giant covalent SiO2 is giant covalent. By the way, we're actually going to run Susan Boyle twice here. So structure, bonds, strength, number, energy. SiO2 is giant covalent. Unlike, we just do them next to each other. Unlike SiCl4, simple covalent. We can actually do them side by side. So SiO2 contains only covalent bonds. Covalent bonds. SiCl4 has weak intermolecular forces. WIMPs. WIMPs, weak intermolecular forces, in the exam I'd write down, WIMPs are very weak compared to covalent bonds. Large millions of covalent bonds. Millions of covalent, but few WIMPs. Lots more energy to break SiO2. We're done. That's a horrible question now for 2 marks. Very long-winded, lots of writing. But again, high level. You're talking 7-8 here, folks. Not quite as hard. And you're probably wondering the difference between those 2 questions in level. The reason being is this question here is the students will commonly not realize that WIMPs are cumulative in terms of size, because it's a link to another topic. That there comes from the topic of crude oil. because you learn in crude oil that a short chain like propane will have a lower boiling point than something like octane. And what you say is bigger molecules, stronger intermolecular forces, therefore higher boiling point. So it's a link to a different topic, and that adds a level of difficulty that students often miss. Right, electrolysis now appearing. What a great question as well. They've linked 3 together. That's grim. Name the particle that moves through the connecting wire to form electricity. That's the electrons. So in metals, question?
Well, I'm trying to watch what you were doing for the same question.
Oh.
It's restricted on the school Wi-Fi.
Oh, that's awkward. Huh. Intriguing. I don't know what to say there. I wouldn't worry about it too much if you want to just sit there and go through it as I do. And you can ask me any questions, Alison, that you've got. I'm happy to respond to you. Happy. So just to mention, electrolysis, guys. Electrolysis, one of the hardest topics at GCSE. Everyone hates it. Just to mention, though, metals charge carrier. The metals charge carrier is electrons. We know they have a sea of delocalized electrons that can flow through the structure. But in solutions of ionic, solutions or molten ionic, the charge carrier are the ions. There's no free electrons. Charge carrier is ions. Yeah, there are no free electrons, and they love this. Yeah, they'll say, what particle makes it conduct electricity? Electrons in metals. But then they'll say, what makes the molten compound conduct electricity? It has free moving ions. Yeah. The electrodes are made from platinum, which is an inert metal state. What is meant by the term inert? Unreactive. Can I spell out very unreactive, but they just want the word unreactive. Explain why the electrical cell containing lead bromide needs to be heated before electrolysis occurs. Right. Okay, so they've got solid salt here. This is not dissolved in water. What we know is, in order to conduct electricity, ionic compounds must be either molten or in solution. But they're actually asking us why. So heated, so lead bromide will melt. First mark. So the ions become free to move around, carrying the charge. Carrying charge through structure. Carrying charge through structure. Suddenly realized that my laptop is getting uber hot. Just gonna put my little fan on. My kids in my class are, of course, going to all laugh at me because of my little baby fan. Move my little baby fan. There we go. My little fan is there now, keeping it cool. Keeping it cool like me. Sorry, what? Anyway, so when sodium chloride is electrolyzed, 2 gases form the positive. Can I just point out that question? Right. Okay, this one here is a level 9. Okay, guys, this one's a level 9, and it's a level 9 because it is technically outside of the specification. The reason why. In sodium chloride solution, NaCl, aqueous, in the water is Na plus, OH minus, Cl minus, and H plus. You drink water. These are the ions. So just to tell you where they come from, these ions came from the NaCl, and the H plus and OH minus ions came from the water. Right, so what's now going to happen is we're now going to electrolyze it. We're going to stick in some platinum electrodes. hook them up to a battery, and this is the positive electrode. Positive. At this point, I'm going to remind you of panic, positive, panic, positive anode, negative cathode. Yeah, so we've got the positive and the negative. Okay, so who goes where? The positive one is going to attract the negatives, and the negative one is going to attract the positives. We know this. There we go. Right. So here's the nightmare. First thing, let's do the positive electrode. The positive electrode is annoying. The reason why it's annoying is because you're actually going to get two gases. Now, my year 11s might not remember this from my lesson, because what's going to happen is the Cl- ion is going to lose its electrons and become chlorine gas. Yeah, but here's the other problem. So the first thing I'm going to get is I'm going to get chlorine gas. First gas, number one, a green gas. Yeah, dissolves into the water. But annoyingly, the other ion, can I just point out, the reason why I hate this, and I genuinely despise this, by the way, I despise it because that's going to get produced 98%. And I'm going to form 2% of the other gas. The reason being is the OH- is also attracted and will form O2. And then I need to balance it, which is a nightmare, and it's an alkali equation to boot. So I'm going to have H2O on that side. And then I'm going to need to have four of those and 2 of those, I think. And then I need 4 electrons on that side. That equation you have to learn, by the way. And it's been asked several times now at edexcel. Both of them are losing electrons. Yeah, both of them are losing electrons. Oxidation is loss, oil. So these are oxidation reactions. But annoyingly, both will happen, but only the OH- will only happen 2% of the time. And the reason for that is it is easier to remove the electron from the chloride ion than it is from the OH- ion. It's because the chlorine ion is larger. It's massive, 3 shells, huge. So this is the only time I've ever seen this question asked. In 15 years, the positive electrode will make 2 gases. The first one will be chlorine. Yeah, but I will also get a tiny amount of oxygen. The chances of that's level 9 right there, oxygen. It's never going to happen. It's a nightmare. And then it says what gas is formed at the negative electrode. Now, the negative electrode, the two ions that could go to it are H+ and Na+. But in this case, the second reaction definitely doesn't happen. The reason being is there's a difference in reactivity. This reaction happens now 100% of the time, and the sodium will never collect it. That will not happen. No. And you need to know that, and they're going to have to ask you to explain it. The reason why, hydrogen is less reactive than sodium. So it will gain its electrons preferentially. It's less, by the way, you don't actually need that second bit. You just have to state for 1 mark, hydrogen is less reactive than sodium. Now, just to put this into another question, because this question gets asked in a whole variety of electrolysis, if we did the same thing, but in this time, we did, instead of having sodium chloride, let's do silver chloride. If you do silver chloride, there are the ions from the silver chloride, and here are the ions from the water. In this case, we get a different set of products. We still get the chlorine and oxygen, but the chlorine will be made preferentially. Yeah, the chlorine is a larger ion, so it will lose its electrons more easily. So at the positive electrode, chloride will become chlorine, balance the half equation, electrons on the opposite side. Just remember, by the way, students often put the electrons on the wrong side. Remember that if you have 2 things that are both negative, they're going to repel each other. So you're never going to get this. They would literally push apart. They're going to repel. That's not going to happen. What's going to happen is it's going to be pushed onto the other side of it. The 2 electrons will always be on the opposite, right? And we're also going to get that stupid OH minus. That's also going to happen, but only 2%. But now the negative electrode changes, because the two possible reactions are Ag plus gaining an electron to form silver, or H plus gaining the electrons, 2 electrons, to form hydrogen. And in this case, the second reaction will not happen. And the reason why is silver is less reactive than hydrogen. Less reactive than hydrogen. So it just won't make hydrogen gas. It's going to make silver instead. This is why we silver plate stuff. Okay, so negative electrode is going to be 2 H pluses plus 2. Now notice, this time the electrons are on the same side as the positive charge, because they're going to attract each other. Makes sense? They're going to go together. Give the ionic half equation to show the formation of each gas. That was epic, because if you couldn't do that, you couldn't do this either. That question is level 9. Cl minus going to Cl2 and balance. And then OH minus going to oxygen and balance. No. Oh, that's hard, that, guys. Really hard. Nobody got it. Right, this question, delete. It is no longer required. If you want me to do it anyway, just for fun, during electrolysis, so there are 2 equations you have to learn here. So the first equation, this is calculations. By the way, year 11s, if you're interested in this is calculations of electrolysis. It's not even seen in A-level anymore, by the way. So you technically don't need this at all, but it's nice to see it, because in reality it drops into calcs once you get to the moles of electrons. So if we learn Q equals I times T, what that is current. This is charge. Charge equals current times time. Okay. Next, we also remember that the number of electrons is equal to the, by the way, this is otherwise known, number of electrons, otherwise known as a Faraday. So the number of electrons in moles is Q divided by 96,500, I believe, which is what's called the Faraday constant. Can someone in the classroom, please? Libby, can you quickly Google the Faraday constant? I haven't taught this in a while, and I'd like you to just give me a bit of a check as to its value. 96,485. Fab, that's correct, 96,500. I like it. Yeah. So what we can now do is, so the annoying thing is we've actually, this question doesn't require any of this, because they've already given me a Faraday. And a Faraday is one Faraday is equal to 1 mole of electrons. So we actually drop straight down into the equation. The equation says Cu2 plus 2 electrons goes to Cu. Well, they've told me I've got that many moles of electrons, 0.04. What's the ratio between electrons and copper? It's a 2 to 1. So I just divide it by 2. And I'm going to get 0.2 moles of copper. Now I have to do grams over rams. Number of moles is grams over rams. So moles, I've got 0.02 equals the grams over the relative atomic mass of copper, which is 63.5. Rearrange. 63.5 multiplied by 0.02 is going to give me 63.5 multiplied by 0.02 gives me S to D 1.27 grams. I'm done. Next, right, on to organics. I've only got 8 minutes left. Explain why these 3 compounds, that one, and that one are hydrocarbons. Explain which of these 3. So A, B, and C are hydrocarbons. 1 mark. Question? Of course you can. A, B, C are hydrocarbons. because they only, notice my capitalization, contain hydrogen and carbon atoms. This one is not a hydrocarbon. The reason being is it contains chlorine as well. Explain which compound is shown as a displayed formula. That guy. So it's B, all bonds are shown. That is quite literally the definition of displayed. Next, ethanol can be manufactured from compound A. Right, so my U11s who are currently chatting away in the background, I do apologize, by the way, for the I want to say the noise. I haven't done this with them yet. So this is the manufacturing of ethanol. So ethanol can be made in two ways. It can be made fermentation versus direct hydration. Now, just to tell you that they're both done in the world. They're done for usually very different reasons. Fermentation can be done in the home. It is slow. It takes approximately a week to 2 weeks. It is slow. It produces impure ethanol. It is batch, meaning you've got to start and stop it. A batch process, and it is high labor. All the problems with fermentation. There are pros, though. These are the cons. There are pros. Number one is it's renewable. It's renewable. It's cheap. Like the budgie. Actually, do you know what? You should never really mention cheap because it's actually more expensive than direct hydration, and they're usually opposite, so I won't. It's renewable. It is carbon neutral. Carbon neutral. And that's about it. Direct hydration. Cons. It is non-renewable. What you realize is just learn one and you've got all the rest because it's the opposite. Non-renewable. They're going to run out because we use crude oil. Next one is it requires, other pro, low temperature. Low temp needed, which means low energy. Low energy needs. 35 degrees C. Cons, high temp. About 300 degrees. High temp, high energy. Now, all the others are the opposite. Pros are the opposite. So you realize that there's a relationship here. It is fast. It is pure product. It is continuous. I'm just giving you the opposite of the others. And it is low labor. So they're doing exactly that here. Give two advantages of using each reaction to manufacture ethanol. It's an advantage, a pro. So reaction one is direct hydration. And that is, number one, it is fast and continuous. It's an awful lot of... Reaction two is... say again. Zach, do you have a question? No? Different? That's right. This one is advantage, low labor. No, hang on a minute. Ethanol, high labor. Apologies. Yeah, pro is renewable. Renewable and carbon neutral. Low energy. Low energy needs. Next, use the formula to determine the name of the compound. Oh! Does anybody in the class... Whoa! Oh. Level 9 outside spec? Guys, they did it? Question C, part C of question 4. Guys, they asked you to name a dye. I told you that they'd never do it, and they've made you do it. They're not meant to do that. That's a level 9. No one in in the UK would get that, not a GCSE anyway. That's first year AS. I'm going to ask Amani, name? Perfect. Oh! Compounds. Oh. That's really, really sneaky. I've just walked into their trap, and I should have realized it was a trap because it's beyond. They're asking you to name compound C, which was ethene. That is genius. Compound C is not that. Compound C, it reacts with bromine to produce this. It was ethene. It was the thing used to make it. What a trap. Butene, sorry, butyrene, even butene, butyrene, correct one. State the color of the product when the compound C reacts with bromine. It is colorless. Right. So I'm going to end at this point, just since my lesson in school is coming to a close. I think we're nearing the end of the. Oh, there's still a bit to go. So I'm going to end part 1 here, guys. So those people on the stream meter, for example. There we go. I'll unstop sharing my screen, bring it back to there. There we go, guys. So I'll leave you guys be. Have a good rest of your day. I'll do part 2 tomorrow. Done. That was so sneaky that even caught me on that one.
Would it be on the test?
Such a cool absolutely caught in that. See you later, guys. Have a good day. Have a nice lunch. Helpful? Can't believe I got caught on that. Correct. Explain how the method is related. Yeah, but it should say no information of the product. Yeah, be able to follow the extraction process is given appropriate information. Detail on the process is not required. That is what they added in and hated. Because the thing is, because they haven't. You think this is what drives me nuts. If they make changes to the spec, they should make changes to the questions. Yeah, they haven't. What will happen is instead of they'll give you a blast for this now. Actually, that's not.
Was it the other 5 years ago?
They made that. No, that changed really recently. Like
Yeah, no, but the test is 5 years ago. No, the test is.
So they knew that spec change was going to happen. Spec changes. That's why we know the spec changes will happen every 3 to 4 years because they're fine for.
Also, are all trade visa in
Yeah, but pretty much the only thing that's now not on the test is all stuff that 9 is, which is like crude oil and combustion, and that's basically it about point. There's no alkenes, there's no alcohol, there's no carboxylic acids, there's no esters, there's no carbons.
What about like the bromine water?
Test for alkenes would be there, like yes. It would be silly if it was. It shouldn't be. Because the thing is, no, because you do cover alkenes, and it's just a test for alkenes. So it could be there.
Okay.
It wouldn't ask you for any equations, but they would just say, Stephen adds down in why would they get these things electrolysis alkene? No change. Remember, do not write down no observation. That's basically doing the test.
Is that the one?
That's what I was doing at AS. A couple of years back, who did that?
No observation.
And you noted every single
Oh, this is the AS paper.
I am Mr. Duncan now.
This is the AS paper.
He lost.
Let me measure my pick.
20%.
Let me measure my.
It was like, because he came out and was like, so I got to see it, I have no idea why. It was.
Unbelievable.
What's really weird is as well, they don't say. You know, if you like the same.
You want to say hi?
They should how?
Say hi.
The problem is because no.
I think it's an AS. No, it's AS. It's AS.
Did you measure your head halfway?
Oh, I can't measure my head.
That's
Halfway,
Mr. Duncan.
Mr. Duncan, you forgot to end the line.
I haven't.
I'm waving right now.
It's still live.
Oh, what?
That's
That.
Get out here.
Listen.